microservice decomposition patterns, very basic bit of information about me. I wrote a book called Building Microservices. I wrote that back in 2014. It's released in 2015. I'm in the process actually of writing a second edition. That was what I was working on earlier today. I now actually run my own consulting company doing training, advisory work. I do a lot of advisory work for startups. I do sort of a lot of consulting, obviously remote at this point in time as well, for countries all over, for companies all over the world. I do lots of things in partnership with folks like Container Solutions and obviously Trifork, and I've been happy supporting the GOTO events for many years, and now into the online arena as well. I've also got a new book that was released at the end of last year called Monolith to Microservices. If you go over to my website, monolithtomicroservices.com also works. You can find more information about the book, how you can read it, and everything else. This is really a book as a deep dive on how you break systems apart. And so the talk today is almost like a distillation of some of those ideas. So I've pulled out a few key ideas and concepts from that book to share with you today. There's a lot more detail around these topics that we can explore in the Q&A, but also a lot of questions that are answered in this book as well. And look, you might have small children at home. You might have, your partners with you. They're also bored. Why not get like 5 or 6 copies of the book for the friends and family? And that way everyone's got something that they can enjoy. So let's talk about microservices. Yes, we talk about microservices a lot, and we see nice sort of pristine looking architectures like this one. Obviously the real world is quite a different thing. But one of the things I talk about with microservices, in fact, I say it's the most important thing to take to heart about microservices, is this idea of independent deployability. This ability for us to go into a system, a microservice architecture like that, make a change to just one of the parts of that system and deploy that change without having to change the rest of the overall system itself. And this is something that we that sort of is very, very important to, if you can achieve independent deployability with your microservice architecture, the chances are you've got a lot of things right about your system. And we compare microservice architectures very much with microservice architectures instead. Let's double check. So we should compare the microservice architectures with monolithic architectures, right? And this talk is about going from a monolith to microservices. So we should probably talk about how we compare what a monolithic system is to a microservice architecture. The first thing I'd say is monoliths are not bad. And there has been this issue that I've seen, especially over the last 3 or 4 years, where we don't say the word legacy anymore. We say the word monolith, and we're using the word monolith to mean anything we don't like. And I think that's a real problem. When I speak about a monolith, I'm speaking about it primarily as a unit of deployment. So your whole sort of system, if you have a monolithic system, the whole thing has to be sort of deployed together. Whereas with a microservice architecture, we're able to deploy independent components separately. This idea that monoliths equal bad is a problem because it then makes the assumption that microservices are always right. There used to be this phrase that you never get fired for buying IBM. The idea being that, well, everyone else is buying IBM products, so I should buy IBM products. I can't possibly get it wrong, because if it turns out not to be right for us, I can always say, well, everyone else is doing it, so how could I have got something wrong? And we're seeing the same things in microservices now. It seems to be the default choice to pick a microservice architecture, and there's this assumption that monolithic architectures are bad, and that's not true. Microservices are a choice. Most of what I'm going to be talking about today is assuming that you've done the critical thinking around, yes, microservices are right for us, in which case, how would we migrate from a monolithic architecture? Monoliths themselves, actually, when you think about them as units of deployment, do come in lots of different shapes and sizes. We've got the classical kind of single process monolith view. All of my code is packaged together in a single process. All of my data is packed up into a single database as well. And if we've got lots of people working on this monolithic system, it can be a bit of a challenge, because we're all sort of treading each other's toes in terms of the changes we need to make. If multiple teams are working on that monolithic system, they all have to sort of coordinate around that activity in order to make deployments happen. So we're all having to work together to make a deployment. There's lots of coordination needed around the deployment of, say, a single process monolithic system. If you've got 4 or 5 people, a small team, these systems are absolutely fine, right? When you've got hundreds of people working on something like this, they become problematic. A variation on this approach would be something like the modular monolith. So with a modular monolithic system, we've taken our monolithic architecture and we've broken it down into modules. If you think about, say, Java, for example, these might represent different jar files. So these modules can be developed independently, but they need to all be packaged together as part of a deployment. So you might be able to do independent development of a module. So a team could work on module A, for example. They could do their own tests around that. But the activity of rolling that change out requires all of those modules to be packed together and deployed. So we still have a single unit of deployment. I actually think this is a very good approach for lots of people. It's highly underrated. I think an awful lot of people would be better off with a modular monolith than they would be with a microservice architecture. I think the issue is that people don't have a good enough understanding about how to draw module boundaries and how to maintain module boundaries. And this is because, after all, the concept of modular software is based on cutting edge work from the mid-1960s, which we still haven't really taken to heart. There's an extent to which microservice architectures are sort of a more of an enforced boundary because they're harder to change the boundaries. So it's harder for us to sort of let these boundaries sort of dissolve. But this can be a highly effective way of allowing some degree of independent work without necessarily requiring a more complex deployment topology. We then move on to some variation on this approach. And here's where we've taken this idea of the modular monolith one step further. And here's where we've actually said, well, the data for each module is also separated. Now, this means that we sacrifice things like transactional integrity across our data stores, and arguably it looks like quite an odd architecture, but this is actually a very good sort of halfway house architecture between the modular monolith and a microservice architecture. By keeping the data for the different modules separate, we increase the amount of independence between those teams. This is really effective when you think you might move towards a microservice architecture later on. The first time I saw this pattern used was actually when I was still working in a company called ThoughtWorks, and a colleague there at the time, Peter GitHub-Moss, was working on an internal project, and he said, this system we're building, we think it's actually 3 separate services, but we don't necessarily want to make that decision now. So we're going to run it as like one application with 3 different modules inside it. Those modules have their own data stores. And then later on, we'll be able to more cleanly separate it out. The idea here is that one of the more difficult things in decomposing a monolithic system is dealing with the data tier, something we'll talk about a bit later on. But that actually, by doing this approach, you've already separated the data tiers in advance. When I work with startups, and with startups especially, I tend to be quite conservative around the use of microservices. In fact, I've just started a YouTube channel. My first YouTube post is, should microservices use should startups use microservices? And my answer was no, because with a startup, like you've got a small number of people, you're focused on trying to get a product out. You don't want to spend your time trying to build a distributed system, right? Most of what microservices do, they solve problems of scale. Scale in terms of number of features, scale in terms of like load, scale in terms of number of developers you've got working on the system. You don't have those issues as a startup. Focus your time on building a product that people want to use. But you could do something like this and hedge the risk, or hedge that bet, right? So now if later on module E is something I want to pull out as a separate service, then I can. When I spoke to Peter about a year ago, this would be 7 or 8 years after we had that, or 6 or 7 years after we had that original conversation, he said, actually, the system we created is still running like this and it's fine. The nice thing about this kind of architecture, and maybe the single process monolithic architecture we looked at before, is that they are very, very, very simple distributed systems. So a distributed system really is any system where you've got multiple processes communicating over non-local networks. Here, of course, all of our code might be packaged up into effectively a monolithic deployment, although a modular monolithic deployment, but we are talking to databases, right? When you talk to a database, that's typically on a separate machine. You have a distributed system. When you put data into a browser that's not running on the same machine as the process, you've got a distributed system. You just happen to have a very, very simple one. with a microservice architecture, as we break things down into smaller and smaller pieces, we've got a much more distributed system. It becomes more complicated to deal with. One of the most problematic types of distributed system is a thing called the distributed monolith. And this is where you have a distributed systems architecture, some form of service-oriented architecture maybe, but for whatever reason, you have to deploy the whole system together. This might be because you've got functionality that's sort of spread over different layers, different parts of your system. Maybe because you're doing maybe more of a horizontally layered system rather than a vertically sliced system, which is what we typically think of from microservice architectures. It might also be because of something like a release practice. You might use something like a release train idea. And a release train idea can be effective as a technique to help you adopt continuous delivery, but too many teams stick with the release train for too long. They say, right, we're going to release our whole system every 4 weeks, and then everything gets released together. If you are doing something like a release train, what you really want is a release train on a per service basis, not for the whole system. But if you've got a distributed monolith, what you'll see is, okay, I want to make a simple change, but I still have to release the whole system together. So even if this could be because the architecture is really coupled, or it could be because your delivery and development practices don't allow for independent deployment. The problem with distributed monoliths is that they tend to have a much higher cost of change than simpler monolithic systems. They also have a much larger scope of deployment. There are more things to go wrong here. So you've kind of got the inherent complexity of a distributed system that we'll get with a microservice architecture. But we also have sort of the deployment downsides of a microservice architecture. We have to deploy the whole things together. And distributed monoliths tend to have all the disadvantages of monoliths and all the disadvantages of microservices without enough of the advantages of either for them to, actually be of use. And one of the tricks often when adopting a microservice architecture is how do you avoid building a distributed monolith? And the answer there is actually quite straightforward. It's like, can you make a change to a service and deploy that change into production without having to do anything else? Not just the fact that you can do it, it's that you actually do it. Your normal mechanism for delivery is you make a change to a service and release a service independent of other things. If you do that, you're fine, right? If you find yourself releasing large clumps of services together, you're on that slippery slope to a distributed monolith, and pain and suffering may be in your future. So, distributed monoliths, not a lot of fun. So back to our microservices, right? What we're looking for here is this idea of independent deployability. Right, this is the alternative. We've got a system that previously may have been a single process, but we can take a microservice and we can deploy that microservices independently of deploying anything else. Great, fantastic. So the question then is, how do we get to something like this from, a big box? Because most of you, I would imagine, you're not starting from scratch. You have an existing system that does something, and you're interested in taking that system and migrating it to a microservice architecture. And that's the situation that most people are in. And I think that the challenge we've got as an industry is that we've got quite good at sort of doing code refactoring. Refactoring, if you remember, is so refactoring is something which changes the structure of code, but doesn't change the behavior. And we're very good at refactoring code nowadays, but I don't think we are very good at refactoring architecture. We see the architecture of our systems, as something which is very static, that can't easily be changed. I don't think that's actually true. I just think we don't share and talk enough about the patterns that enable that kind of refactoring of architecture. And that's what I'm going to show you today. I'm going to show you some refactoring patterns. So when I'm thinking about taking a system like this, and I want to break this apart into smaller pieces. So the next question is, well, where do I start? And so really there we need to think about, well, how do we even identify for an existing monolithic system what my service boundaries might be? And I've talked before here about the importance of something like domain-driven design. So microservices are, the prime way we find microservices boundaries. There are other techniques you can use, but primarily we're looking to identify boundaries around parts of our business domain. And so these, the first thing I would do with an existing monolithic system is to say, okay, well, do we have a sense of what the business domain is for this monolithic system, and try and do some sort of domain modeling exercise, maybe something like event storming, to project onto that monolithic system a sense of the different parts of that domain model. So I can, and normally the sort of default approach, if we were taking this approach, this sort of direction, would be to map what we call the bounded context from domain-driven design to a service bound, just as sort of a good starting point. And so we can say, well, inside my monolithic system, I've got invoicing, I've got order management, I've got something like the loyalty, I've got shipping, I've got inventory, payment management. Also coming out of something like an event storming exercise or any kind of context modeling exercise would be a sense of how all of these different domain concepts relate to each other. And so hopefully you come up with sort of a directed acyclical graph, like a logical view of the business domain you're operating in. So here, for example, I can see that like lots of things end up depending on the ability to send notifications to our customers. And that's something which kind of already is useful information. If we're thinking about a migration activity, right, we're talking about taking bits and pulling it out and learning from that and, doing piece at a time. So we could say, well, what happens if we extract the notifications functionality from our system? Now, looking at the understanding from our logical model says, well, look, notifications is used by lots of people. So we could probably assume that our code, that the notifications related functionality in our system is also likely to be kind of quite deeply tangled into our system as well. Lots of things depend on it. That might mean if we extract that notifications functionality, those sort of logical links from our domain model would relate to actually code dependencies in our code base. And those code dependencies, which would previously now have been calls to say an API, ideally within our existing monolithic system, those things may now need to be made and changed to service calls. So when you get something that's quite core to your domain that has lots of inbound dependencies, extracting it is likely going to be more work because you've got more dependencies on it, and it's also more core. So if you make a mistake with it, the impact could be greater. On the other hand, something which is sort of higher up in your stack might be easier to pull out, like pulling out something like invoicing. On the face of this sort of thing looks like a more straightforward activity, partly because it's not as core. Nothing depends on it. It only depends on other things. That would open it up to the use of, and probably something like invoicing would likely be something that's quite high up in your call stack. And as a result, might be quite amenable to something like a Strangler fig application pattern, which is one of the patterns we'll talk about in a moment. So that on one hand, we can talk about what's easy to extract and what's hard to extract. So notifications look like it might be easier than, so this might be harder than invoicing. So we could say, well, let's extract invoicing. But the reality is, microservices aren't really an end goal, right? If you're thinking about adopting microservices, you're thinking about adopting microservices in order to solve some problem that you've got. At least you should be. Okay, and the problem isn't that you don't have microservices, right? Microservices shouldn't be like done without careful thought. So what is it about your current system architecture that doesn't let you do what you want to do? And so what is it you think you're trying to get out of microservices? Because that's going to drive this prioritization quite strongly. So we could say that invoicing is really too easy to extract, but if extracting invoicing doesn't actually help solve your problem, then what good is it? If your goal is to scale the system because currently you can't handle the load that you're looking at, and invoicing is not one of your sort of highly contended bits of functionality, then yes, extracting invoicing might be might be easy, but if it doesn't actually help you increase the load that your system can handle, there's no point extracting it. So you've always got to be balancing these forces off. When I talk about adopting microservices, I sort of also kind of want you to have this idea that it's not about an off or an on state. It's not a binary state with microservices. You want to think about adopting microservices much more like turning a dial. You start with that dial at 0, and then you add more services, and you keep turning that dial, and you add services, and you turn that dial, and you add some more services. And and what you're doing is you want to get a service, add the service, see if it's solved your problems or made your problems better, learn from that experience, add another one, add another one, add another one. You keep turning that dial up. When you hit certain points where you start seeing more pain, you'd stop and say, okay, well, maybe we need to turn it back down again, or maybe we need to bring in some new technology or a new skill or a new way of working to solve that problem before we keep turning it up. What you don't want to do is sort of turn the dial right round to 11 and then plug the headphones into your stereo, right? Because your ears are going to go pop. Same things happen with microservices. If you go from 0 to 11 with your microservices, you're likely going to have a nasty time of it. And because this is all the thing, you know, you've also got to work out how far do you want to turn that dial. You know, are you an organization which actually needs 4 or 5 services? Who cares? Great, use it. Just because Monzo has 1,500 services doesn't mean that it's going to work for you. It works for them. It may not work for you. Monzo didn't decide on day one of the company, let's have 1,500 services. They have got there over the period of time and lots of decisions being made, and that's how they find it easiest to run their business. For you, you might be at the extent of having 2 or 3 services, and that's fine. Everybody gets it to be in control of their own dial. So you've got to think about what it is you're trying to achieve. You turn that dial up gradually, see if you've made things better, and you learn from that. The reality is you're not going to understand the true horror, pain, and suffering that comes from running a microservice architecture until you're actually in production. And so when I talk about decomposition here, when I talk about turning that dial, I mean turning that dial to the point where these things are in production, serving real production load. So you need to get that functionality extracted a piece at a time from the monolith, get it integrated with the monolith, running in production, and that's where you're going to see how it works. Did it to solve what you wanted it to solve? And if it did, you go again. If not, you change something else. To paraphrase Martin Fowler, if you do a big bang rewrite, the only thing you're guaranteed is a big bang. And look, I like explosions, but not in my IT projects. So what we need really are patterns that help us take our systems and help us incrementally change them. We need architectural refactoring patterns. And one of the most effective architectural refactoring patterns in this particular space I found is a pattern called the Strangler fig application pattern. It was actually inspired by this type of plant from Australia. So what we actually see here is a tree that's wrapped around with another fig. And over years, over decades or hundreds of years, this vine that's wrapped around the tree becomes bigger and bigger and stronger, and it can eventually stand by itself. It doesn't need the underlying tree anymore to support it. But without the tree, the fig doesn't really exist. And when we think about using that Strangler fig application pattern in our own software as part of system migrations, we use the same approach. So we take the existing system that does everything we need it to do, which is your monolithic system. We incrementally wrap our new functionality around it. This is going to be our microservices. Calls that come in to use functionality, where that functionality has been migrated to, say, a microservice, that call gets diverted to the microservice architecture. If the call to functionality if that functionality hasn't yet been migrated, the call doesn't get diverted and it carries on to the monolithic system. This gives you a way of incrementally migrating functionality, often without anybody upstream being aware of that. There are lots of different ways of implementing a Strangler pattern. I'm going to take you through probably the most simplest example of this, but it's applicable as a more general pattern elsewhere. And really, to implement a Strangler, you kind of need 2 things really. The first is this: you need to identify the functionality that's going to be moved, and then you need to be able to redirect calls. And that's kind of it, right? And I talk here about movement of functionality. I'm moving functionality from the monolith to the microservice architecture. You might be lucky, right? So you might decide, okay, I'm going to move notifications after all. And oh, look, all of my notifications functionality is in a nice little class. I can just copy that code and paste it into my service boundary. More often than not, that's not necessarily possible. Maybe the code isn't nicely factored. Maybe you're changing programming languages. So a lot of people also will actually rewrite that little piece of functionality that's being moved. But note here, I said copy and paste. When we move functionality from the monolith to microservice architecture, there's a lot of value in leaving the functionality in the monolith for at least a short period of time. We'll come back to why in a moment. So here's the simplest type of monolithic to microservice migration pattern using a Strangler fig. And in this example here, we've got a monolithic application which is being driven via HTTP. And so at this point, we're doing interception maybe beneath a UI level or maybe an API level. Now, I've used this to do actually, you can use a Strangler pattern actually at the UI level as well. This is sort of just underneath the UI level. So we've got HTTP calls that are coming in. One of the benefits of HTTP is it's quite easy to divert those calls, without the client needing to be aware of that. So we're going to need a diversion and a way to divert calls. So we need to put a proxy in between the upstream calls and the downstream calls. And I'd roll that proxy out, stick it between the upstream and downstream calls, and I would do nothing else at this point. I'd roll it out into production, just make sure it works. What we're looking for here is we've added a network hop. And so what we want to make sure is that when we've added that network hop, that we have an increased latency to a point where that is unsustainable. This should not add much latency to your calls, but it will add some. It may not be measurable. But I've definitely worked in situations where we've discovered that the actual quality of the network is so poor that adding network hops was just adding too much latency, in which case you need to find that out early. And putting a proxy in it does nothing other than just lets the calls pass straight through it. That's enough often to just see the impact of an additional network hop. So I'd let that run for a week or two, get tracking of all the requests that are coming in. Next thing I do is I start working on my service. This is invoicing service. So I start working on that new invoicing service, and all this time I'm making a change and I'm pushing it to production, making changes, pushing it to production. I can do that safely because until I divert the call, the functionality isn't live. This gives me an opportunity to make sure the deployment process is working. I can test it in situ. And when I'm ready, all I need to do is change that proxy configuration to divert the call to invoicing to the invoicing service. If there's a problem, that invoicing functionality still exists back in the monolithic system. So I can just change that proxy configuration and divert the call back. No harm, no foul. So this works with a really nice pattern, works really easily. I've shown it here work with HTTP, but I've done it with user interfaces. I've spoken to a team last year called HomeGate, based in Switzerland, and they'd actually used they'd done interception at the FTP point. So there's lots of different ways you can use a Strangler pattern. And I've also used it for doing monolith to monolith migrations as well. And it's so easy, it doesn't look like it should be as useful as it is, but it really is. There's a whole host of other benefits that come from something like a Strangler fig pattern. Now, a Strangler fig pattern would work quite nicely if we look at something like, say, where's my pen? So if we looked at something like, say, invoicing, order management, the Strangler fig would work quite nicely there because they're going to be likely high up in our call stack. We're more easily going to be able to map calls coming in to the functionality that we're extracting. But if we think about things like, our notifications functionality or loyalty functionality, those things aren't going to be easy. We can't get those things. The Strangler pattern, a call doesn't come into the monolith that says, add points, right? How do I get rid of that? There we go. That's really interesting. Anyway, things I've learned today is that there's no delete all function on the iPad app for, on the iPhone app for Zoom. So I'll just scroll that out. So if we look at something like loyalty or functionality, so loyalty or notifications functionality, there's no call that comes into our monolith that says add points. What actually happens is a call comes in that says place order. As a side effect of placing an order, we add points to people. So that means we can't intercept things and calls into the system at the perimeter of our monolith. Instead, to extract things like that, we're going to need to get inside the monolithic system. And here's another pattern that could be quite useful, and that's a pattern called branch by abstraction. Oh, goodness me. So the branch by abstraction pattern is something you may have heard of in the context of trunk-based development, but it turns out to be quite useful here as well. In fact, it's useful in any situation where you want to replace an abstraction, because it allows you, the branch by abstraction pattern it allows you to coexist two different implementations of the same abstraction and to basically replace one with the other. And that's worked really effective in this situation. So here we are inside our monolithic system. We've got our existing notifications functionality. And the first thing we're going to need to do is to create a clean abstraction point. And so that might mean going into, say, the invoicing code, going into the orders code, and saying, look, rather than directly calling these SMTP libraries or directly calling out to Twilio to send SMSs or whatever else, instead what we want you to do is actually call, say, a notifications interface. And so we take all that notifications functionality and we refactor it and put it behind a clean abstraction point. So now the invoicing and the orders functionality makes use of a notifications interface. And if you're using dependency injection, you would inject that in maybe at runtime. And so that is just a nice bit of refactoring. We've made our code, more composable. We've cleaned the monolith up. It's a nice, safe bit of work as well. It's an easy refactoring to do, relatively speaking. If you're using a statically typed language, refactoring of this nature is really not that hard. And if we do nothing else, we've now got a nicer code base, which is pretty good. So if you stop the work at this point, we've left things in a better state. The next thing we're going to do is we're going to create a new service implementation of our notifications. And that has got two bits. The first part is effectively the client code that's going to run inside our monolith. And that client code is going to implement that same notifications interface. It's then going to delegate calls to our service that's running outside of our monolith. This is our microservice. So when the notifications when that notification interface gets called, it can call out to our service instead. Now at this point, I will be checking in my service calling implementation. That client code that I'm checking in, where am I? This code here, for example, as I'm checking this in, it's totally safe. I can check it in, I can test it, I can deploy the code, and that's a safe operation because it's not being used. Until I do the switch, until I do the switch over, then that functionality that I've been working on hasn't been kind of released to my customers. It's deployed, but it's not released. Once I'm happy it's working well, I can switch that functionality over, and all I need to do there is just change which implementation of the abstraction we use. And that would be something as simple as a feature flag around the injection point. Once it's all working well, I might be able to I can remove the abstraction point if I want to. It's a great book that will talk covers some of that refactoring in more detail. It's a book called Working Effectively with Legacy Code by Mike Feathers, and that takes you through this process really of creating new abstraction points in your code, and it's a really, really good read. Now, one of the things we've done there is with both the Strangler Fig pattern and with the branch by abstraction pattern, we have a situation where we've got both the old and the new implementations of our code running at the same time, and we're able to choose which one we're running. And that could be quite useful. We can do things like a parallel run, for example, and that could be rather than running one of the implementations or the other, I could actually run both. And that can be really effective. We want these things to be architectural refactorings. A refactoring, as I said earlier, is something that changes the structure of our code, but not the behavior. So if we execute both implementations of that functionality, we can actually compare the results and make sure they're behaving in the same way. If I was doing this for notifications, I would have to be a bit careful about how I do this. I don't actually want to send an email twice, but what I could do is have my notification service talking to, say, a dummy SMTP server. I could make sure that that works properly, make sure that it happens within a sort of an acceptable time frame, because you can also compare the non-functionals around the new implementation as well. This is actually a technique, this sort of parallel run idea is a technique that a lot of organizations use, and it's a really old pattern, right? I talk about it in the context of microservices in the Monolith of Microservices book, but lots of people are still using it now, and using it rather than at the big level of the whole systems, and also just at different code abstractions. One company doing this is GitHub. So GitHub created a library called GitHub Scientist, which is a little Ruby abstraction where you can actually compare and contrast two different implementations of the same abstraction to make sure the new implementation is working effectively. So they sort of describe this as a tool for working with refactoring of critical code paths. Scientist is sort of as being ported to a whole load of different languages, by the way. Inexplicably, there are 3 different ports in Perl, so go fill your boots there if you want to try this stuff out. A few times now, both when I talked about the branch by abstraction pattern and also previously about the Strangler Fig pattern, talked about this idea of, well, we're deploying our new microservices code and then we're releasing that code. It's deployed in production, but until we divert that call, it's not kind of live. And this comes back to this idea of trying to separate the concepts of deployment from the concepts of release. And for too often in our heads, we've conflated these two ideas together. The act of deploying something is also the act of releasing it for many of us, but that doesn't have to be the case. And if you can separate these two ideas, you open up lots of interesting possibilities. There are a whole load of new sort of deployment techniques that fall under the banner of what now is called progressive delivery, which sort of embrace this idea. It's a great post by James Governor over at Redmonk all about this. So you think about something like a canary release, where you release a small portion of that traffic. A small portion of your customers see the new version, but most see the old. So if there's a problem with the new version of the software, it only affects some people. A/B testing, diverting some portion to one and some portion to the other, so you can compare. Parallel runs, executing both implementations of this. Blue-green switchovers, dark launching. There are many other patterns under the banner of progressive delivery, but they all really come back to this idea of, look, conceptually, there's the act of deploying the software, and then there is the act of releasing that functionality to our customers and to our users. And if we see that act of release as being a separate step from the act of deployment, we actually have a whole load of things that we can do around de-risking our rollouts. In turn, that's going to make us braver in releasing functionality more often, because a lot of these techniques are all about helping us catch problems when they occur. So, think about this idea. Progressive delivery is really interesting, so do read up on that. I'm sure some of you are doing these things already. Okay, so let me jump forward just a little bit. Now we need to talk a little bit now about databases, because so far we've not talked about data, and databases are where this thing gets kind of tricky. And so I'm going to take you through kind of just a kind of a brief overview of this stuff. Although I would say that the data side of this is probably the thing I spent most time on in the new book, and it's the biggest chapter in that book is like 20,000 words just on databases. There's a lot more information out there. But we have got this challenge with microservice architectures, is that we've to make these things independent, we don't want to share databases. And I'm not going to go over why, because there's lots of information about why you shouldn't share databases, but I'm just going to take that as a given and we're going to move on. But that means that when we're thinking about system migration, we have to deal with the fact that we do have one big giant shared database. What do we do about that? So in this situation here, I've got my monolithic applications, and I've sort of extracted the code related to invoicing, but my invoicing service needs some functionality that lives somewhere else. So what are our options in this case? Well, the first option is just to directly access the data, right? But we don't really want this, right? This causes all kinds of coupling. Now, I would say if you're going to do this for a short period of time, perhaps during the process where you're doing a switch over from one system to another, like you're doing a parallel run, for example, this is the only game in town for a short period of time, but you don't want this longer term, right? Because we want to think about our microservices like they're black boxes. You want to say, well, actually, I've got, rather than letting someone directly accessing my data, because once you directly access my data, I can't easily reason about those parts of my system that can be easily changed. I don't know which parts of my database are being used now. What I want to do instead is say, well, look, my service rather, is basically a black box. If you want to access my functionality, you have to come to a well-defined service interface. I'm hiding the information about how my system is implemented. If you want data from me, you come and ask via maybe an API call, or you subscribe to events that I'm publishing. That allows me as a developer working on the shipping service to understand which parts of my system can change easily and which parts of my system have to stay the same. So what that means is that although we might have a shared database for a short period of time, we actually want to stop that from happening. So the next question is, if I'm the invoicing service, what data is it that I'm trying to access? If the data I'm trying to access is actually data that should stay in the monolith, for example, I'm accessing order-related information. Well, order-related information is still owned by the monolith. The invoicing service doesn't handle orders. The state machine for managing, state mutations around order-related information, that is still in the monolith. So as a result, it makes sense for me to go to the monolith via a well-defined service interface and ask for the data I want. In this example here, we've exposed, say, a REST-based API on the monolith. Now, don't call it the monolith API, right? But maybe call it, well, if it's the orders data, call it the orders API. And then I go, the invoicing service, I go to the orders API to fetch the information I need. That I don't really know from a consumer point of view that that happens to be served by the monolith. It could be another service for all I know. But that keeps that nicely hidden. Right. That's interesting. Hang on a minute. I just need to pause for a moment. Okay, so I do this a lot. I've just made spill water all over my desk. So that's great, isn't it? So I'm going to talk and mop. So when you've got situations where your functionality needs data and that data is not yours, you want to go to a well-defined service interface. Don't go to the database in here. So here, let's imagine it's the orders information that I want. I go to the monolith and fetch it. That gets kind of interesting then, because now I'm having to define an orders API from sort of the outside in. So I'm thinking, okay, well, looking at the monolith, this orders information sort of exists there. It's something that I can use, I can gain. I'm sure some of you have seen the film Alien, right? There's a scene in Alien, probably the most famous scene in Alien, where basically this alien sort of emerges from John Hurt's stomach, right? Brilliant actor, John Hurt. And it's kind of quite a gruesome scene. I know spoilers, but like Alien's an old film, so I'm sure you'll survive. And so the way it works is, John Hurt's there writhing around, and you start to see this alien sort of starting to emerge from his stomach, and then finally it rips out. And this can actually happen in these situations here. I mean, not the alien side. I mean, this is an analogy, right? But when you're looking on the outside of a monolith, you're starting to sketch out the API of what you need to access from inside that monolith. It's almost like you start seeing a new service that's striving to get out. So maybe here it's the orders API just wants to be ripped from out of the monolith. So this sort of outside in looking can help you kind of identify another service that might want to come out. Now, of course, this is the easy stuff, because the harder piece is when you actually have to move data. So let's imagine that the data that you want to extract is actually, it's your information. So what data I want? I want invoicing data. I am the invoicing service. Well, then I have to go get some invoicing data, I guess. So I've got to pick up that data and move it over to me, move it over into my world. That's where things start getting difficult. And of course, for that case, the monolith is now going to have to call out to me to fetch the information that it needs. And this basically means that we have to dive into that database and rip that data out, just like the John Hurt thing again. Now, what I'm going to share with you is just one example of refactoring, as there's more in the book. I am actually, though, going to give you one of the nastiest types of refactoring you'll have to do. And that's something that involves basically kind of dealing with sort of foreign key relationships and the like. And I am looking at these primarily, from sort of a relational database point of view, which in many cases is often the worst case scenario. Most of the techniques I talk about in the book are applicable to non-relational databases. Well, in fact, non-relational databases, you often got more freedom around these things. But fundamentally, the thing that makes relational databases powerful is also the thing that can make relational databases difficult to work with. So if you're looking into just quick tips around refactoring databases, this is a good book. It's quite an old book now, but it's still a good book talking about how to do refactoring databases. I'd also recommend getting some kind of tool that allows you to version control your database refactorings. A tool like FlyawayDB would be a good starting point. What you're looking for here is something that allows you to define version controllable Delta scripts to sort of deterministically make changes to databases. Flyaway tends to be my tool of choice in this space nowadays. Let's take a look at our example. And I'm going to be honest, I'm throwing you in at the nastiest example I've got, because we only have an hour together and I want to start you off with something that's difficult. So here we've got some functionality. We've got an existing system, and what we do is we sell compact discs, CDs online, right? It's a cutting edge business. And we've got, in our existing monolithic system, we've got some catalog related functionality. And this stores information about how much albums cost. And then we have our finance functionality, and this is what stores purchases. And we store purchase information, what gets bought by people, that goes into a ledger. And periodically, we need to generate a list of the top 10 best-selling acts. So not best-selling acts, but the best-selling albums. So every week, we need to say, okay, this week, the biggest seller is the Best of Def Polka Volume 4. Now, to do that kind of query in this system is quite straightforward. I'm going to go to the ledger. I'm going to read data out of the ledger. And I'm going to look at the ledger. I'm going to look at the ledgers, the entries in the ledger, the insertions in the last week. I'm then going to group them by the ID of the album that we sold. So in our case here, that's going to be the SKU column, right? So I'd group by the SKU. That's the ID of that record that we've sold, and then I can report that back, right? But the problem is if I just pull back the IDs of the album that we sold, that's not much use. If I'm trying to make a web page of this, for example, I need to know the artist as well. But the artist information is over here in the line items table. So what we need to do is we need to do a join. So we'll join using that ID onto rows in the line item table so that we can pull back. Well, the biggest seller this week was ID 123, and ID 123 is the Best of Death Polka Volume 4. The problem is if catalog and finance are going to become separate services, then this join relationship can't be allowed to exist, because ledger is going to end up in the finance service, and the line items table is going to end up in the catalog service. So instead, what we do is we need to move that join relationship up into the data tier. So the way that would work is the finance service would go and fetch the top 10 IDs for that week's sales. It would then get those IDs back. It would then take those 10 IDs, go over to the catalog service and say, here's these 10 IDs. Can you please give me the information about these records? So that would get fetched from the database, and then that would be passed back. And this is basically what happens when you don't do joins in a database and you do them in code instead. This is the kind of insanity that ensues. Now, of course, you look at this and it looks pretty horrendous. And the answer is, from a point of view of latency, this is adding a lot more network hops. So if you're building, say, a latency sensitive system, doing lots of joins across systems like this can be problematic. One of the ways that we mitigate these kinds of challenges is around all these round tripping is caching. So in this situation here, I could cache the album information. Where is it? It's my pen. So I could cache the album information in the finance service. It's a completely legitimate technique that would allow for much faster lookups. It would avoid the network round trip. The trade-off, though, would be that I would be relying on cached data, and cached data is potentially, obviously stale. How often does our catalog change, though? If our catalog changes infrequently, that might be a totally appropriate operation. We could talk about caching. I could talk about this one slide and caching for a whole 60 minutes. I'm not going to do that to any of you because I'm sure some of you do have family you want to get back to. But yeah, that's something we explore a lot more detail in the class. So, okay, caching can help us around all this. There's other problems with this decomposition that we've done. So here we are, we've got a line items table, we've got a ledger table, and the line items and the ledger table, we've already said, that sort of ID, that SKU reference there, references a row in the line items table. And this is the reference we use to do our joins. That is a foreign key relationship. Foreign key relationships in relational databases do three key things. The first thing is they make the relationship between these two rows explicit. The second thing they do is they make these join operations faster by telling the database that these two things are related. Behind the scenes, the relational database is actually carrying out optimizations to make those operations quick. The third thing foreign key relationships in relational databases do is they enforce referential integrity. And that's kind of useful, right? So in this situation here, I wouldn't be able to delete row 1, 2, 3 from the line items table, because if I did, that would violate the referential integrity. So the database would say, hang on a minute, you can't do that. I'm not allowing that change to happen. Instead, I'd have to do a cascading delete or delete the other upstream references first. When we move into the distributed system world, we don't have that ability. The first thing is, well, how can we make that relationship explicit? So in this situation here, I've made that, this example here, I've made that relationship explicit by changing the SKU to, rather than being some just random ID, to actually making it what looks like a URI. So this would make sense if you're building, say, a REST-based system, but you can use URIs in other types of non-REST-based systems as well. So this is saying, okay, so if I'm working on the finance service, I see a reference like that, that's sort of saying to me, oh, hang on a minute, that's not that I know from the way that reference is formatted, it's actually something that somebody else cares about, that somebody else owns. If it was a REST-based system, I might be able to directly dereference that to get back the record. In another situation, that might be something I have to pass into an API or something, but making it explicit is useful. but I have no referential enforcement of referential integrity here. There's nothing to stop me deleting row 1, 2, 3 from the line items table. And if I did, I'd have to deal with that situation. So that's a situation that wasn't possible in the old world and now is. So what can we do about that? Well, a lot of people just don't allow deletion in this situation. So they say, well, the catalog should be pretty static. I don't allow those things to be removed. Maybe I add a status column and I say that I mark that as being unavailable rather than, just removing it in totally. That means I'm never going to have sort of a missing reference there. If you wanted to do things like cascading deletes, you could, when you delete a row from the catalog table, have it fire an event. And then when you receive that event, you could then handle that accordingly. In the case of a ledger, you wouldn't want to actually delete the row locally inside your ledger because that's how you go to prison, but you might use that to copy the data locally. So when we sort of make a change like this, we've broken a from key relationship, we've made a move to join operation up into the network stack. We've got a lot more network hops, so the latency can suffer. We've also lost enforcement of sort of the data integrity as well. And there are ways we can deal with these issues, but this is the kind of stuff we deal with. Now, this is one of the worst things you can do when pulling databases apart. And maybe for the first service you extract, this is not the stuff you want to deal with. This is another thing, like when you're starting off this microservices journey, picking something that's easy at the beginning is really important. And actually, if you said, well, the first service I want to extract has this problem, I'd say, can we find something easier to work on? I go into a lot more detail about how you solve all these different issues in the book, and if you come to the class in that as well. There's lots more information about the work I do. More information about the Monitor Microservices book is over on my website. You can also find, I've got a YouTube channel now. I haven't got links to that because that's how bad I am at the YouTubes. But you can find information on my website. If you want to contact me for consulting or all remote, obviously right now, work, there's also my contact details there as well.